number 5 is the same type of problem as number 4. You're making the substitution y equals e to the mx into this equation and then solving for m in order to get the solutions to the equation. In this case, we don't have an initial value problem because you're not given any initial values. So let's make our substitutions just like we did for number 4. We'll start with y equals e to the mx, and then y prime, carry down the m, you get m e to the mx. Second derivative, carry down another m, you get m squared e to the mx. And then for the third derivative, carry down one more m and you get m to the third e to the mx. So when I substitute into the equation, this is a third derivative. When I substitute in, I'm going to get m to the third e to the mx plus m squared e to the mx minus 4m e to the mx minus 4 e to the mx is equal to 0. You have the e to the mx in common, so you can factor that out. Factoring out e to the mx leaves you with a second factor of m to the third plus m squared minus 4m minus 4. Here you can factor by grouping. If I factor out an m squared, it'll leave me with a factor of m plus 1 Okay, from this first group, m to the third plus m squared, you can factor out an m squared. It leaves you with an m plus 1. From the second group, negative 4m minus 4, you can factor out a negative 4. That leaves you with an m plus 1. And then inside the brackets, you have an m plus 1 in common. Factoring out the m plus 1 leaves you with m squared minus 4. And so if you set your factors equal to 0 on the first factor, here we have this exponential function, and we know that there's no solution. On the second factor, m plus 1 equals 0. You get m is equal to negative 1. And on the third factor, m squared minus 4 is equal to 0. You get m squared is equal to 4. It should be a 4. And you can take the square root of both sides. You'll get two answers, plus or minus the square root of 4. Or plus or minus 2. So our solutions, again, are in the form y equals e to the mx. From m equals negative 1, we're going to get y equals e to the negative 1x. I'm going to call that y1. From m equals 2, we're going to get y2 equals e to the 2x. And from m equals negative 2, we're going to get a third solution, y3 equals e to the negative 2x. To get the general solution, you want to put those three solutions together and multiply each by a constant. so that our general solution becomes y equals c1 e to the negative x plus c2 e to the 2x plus c3 e to the negative 2x.